So, hi everyone. First of all, a big thanks to everyone who joined this webinar and spending 60 minutes of your valuable time for this webinar. So, I would also like to thank Analytics Vidhya for trusting me and giving me the opportunity to conduct this webinar. Although this is my first webinar, so I'll try my level best to make it worth of your time. And before we proceed, I would like to give a disclaimer that during the presentation, like I may not be able to see your messages, even if you're raising your hand or saying something, because I'll be presenting my screen. So for this, what we'll do is, if in case you have any doubts or queries, so we'll be having a Q&A session at the end of the webinar, during which we can we'll try to resolve your doubts. Okay. So this is the agenda for. So first of all, topic is introduction to Spark for data engineering, and this is the agenda for today. Although Vikram has given an introduction about me, so I would also like, first of all, I'll be giving a brief introduction about me. After that, we'll be having an overview of the Spark, in which we'll be discussing about the definition of the Spark and very little brief about the Spark. Then we'll be discussing about the history of big data, like because Spark is part of the big data ecosystem. That is why I will be discussing about the big data as well. And why history? Because when relational database and data warehouses were there, so what was the need for the big data? That is why we'll be discussing about the history of big data as well. Then we'll be having a deep dive into the Spark architecture, and after like what are the key components, what are the building blocks of the Spark architecture. Then we'll be discussing about the how to write a Spark application, and after discussing all this, like we'll be discussing about the advantages of Spark, like when there are other frameworks, so why Spark? Why do we need to go with Spark? What are the advantages of it? Then like this will be about the theory, and after that we'll be having some hands-on session in which we'll be doing a small coding exercise to tell you, like to tell all of you that how does it take to or how to code in the Spark. And finally we'll be having a dedicated Q&A session. So let's start. Okay, so first of all, your time. So first of all, my name is Umesh Kumar. I am working as a data architect cum data engineering manager at Decision Point Analytics, which is a Gurgaon-based company. And however, it is having its clients across the countries, across the continents. I have around 13 years of work experience. And as I mentioned, my current company is Decision Point. Prior to this, I was engaged with Cognizant Technology Solutions, Gurgaon location. And there I was working as a project lead. Talking about my recent achievements, first of all, I am a Databricks certified Spark Associate Developer. I also received the annual award from our respected CEO for year 2021. That award name was Roster Manager. Recently, I have become an author as well. Like one of my book got published. That was my first book, Scrum and Simplified Agile Project Management. As the name specifies, this book is about the Agile Project Management. So, publisher Bookboon Learning. And I have also written a second book, and this book is also about to get published in next 2 to 3 months. Apart from this, I have conducted various trainings for in my company for data engineers and data analysts. The topics are SQL, PySpark, and there's a few more topics as well. And my areas of expertise include data engineering, data modeling, relational database, agile project management. Although it's not important, just like my hobbies are reading books and learning the new skills. Now that's enough about me. Let's go to the Spark. So first of all, a very basic definition of Spark. That for this I have taken the reference from the Apache Spark website and as well as the Databricks website. So talking about Spark, a very simple definition of Spark is an open source distributed coding system for large scale data processing. So even if you don't understand this term, the distributed computing, so no need to worry, I'll be covering this. So it was developed by the Apache Software Foundation, and it is widely used for the big data processing and analytics. It also provides a high-level API in various languages such as Scala, Python, R, Java. And using this, anyone can use either the SQL, machine learning, graph computation, or the stream processing. Like Spark supports the batch processing, like the processing of the historical data, interactive queries using the SQL and stream processing, that the real-time analytics, which makes it a versatile tool for a range of data processing tasks. So it is also a better alternative for the Hadoop's MapReduce. We'll be discussing it why. Now, before we deep dive into the Spark architecture or about the Spark, so first we need to understand what is the big data, like why it came into existence, so like what was the need for the big data and what was the need for the Spark. We'll be discussing that. So talk about the big data, the like before we start the history. So first we need to know what is the big data. Again, I'll be taking a very simple definition of big data. Like when we say big data, the one thing that comes to my mind is the huge amount of data, which is in gigabytes, terabytes, and more than that. To like it has basic three pillars: variety, volume, and velocity. When we say variety, like the big data, using the big data, you can connect to a variety of data sources. So that is why variety. When we say volume, volume is the large amount of data or the humongous data that it can handle or store. Then the velocity. Velocity means like it can process the data in a very small amount of time. That is why these are the three pillars for the big data. Now, what was the need for the big data? So for that, first of all, we need to go to the like the computer. So initially, initially what happened was during the industrial era when there was a lot of manual work. So first thing was computer that came into existence for automation. So if you think about the computer, like the initial days, so the two main operations that it does was, first of all, it was used for the basic data storage, and second was the processing the task. So during that time, if anyone has stored the data, the primary means of storage was the files. Though, like there can be any kind of file, like it can be Excel, it can be CSV, or the text file, or the Word file. So data could be stored in the files. So after some time, like when the data started growing, so the companies wanted a central repository such that they to have a consistent data. For that, relational database was implemented. So relational database was better than storing the data in the files in terms of, because it allowed data to be stored in the form of rows and columns, that is in the structured format. It also allowed the data to be stored in the normalized format, such as to avoid the data redundancy and to format and to remove the data duplicacy. So this was working perfectly fine, and these were most optimized for the read and write operations as well as the transaction processing. However, with the time, like as the time started growing, data also started growing. So at that time, there was a need for one more solution, like which could deal with the historical data and also could be utilized for the analytical and the reporting purposes. For that, data warehousing were they were optimal for the historical data and the analytical processing. So this was working perfectly fine. However, with the advent of internet, so data started growing exponentially. Why? Why? Because now number of the user base for the internet was increased. So people from all over the country, all over the world started using the internet. That is why the data started growing exponentially. So at that moment, like the database and data warehouse, these were the only solutions, and it was difficult to store and process the large amount of data in a single machine because of the storage limitations. Now, with the time, it became evident that single node computing system. When we say single node computing system, node is a synonym for the computer system. Okay, so as we were discussing about the database and data warehousing, so like data warehousing were optimized for the historical data and the analytical purposes. However, with the advent of internet, it became difficult, as the data started exponentially because of the increased user base. So it was difficult to store and process the large amount of data in a single machine, because every single machine had certain limitations, either in the form of storage, the limited storage options, and the limited processing. So it became evident that single node computing system, they were no longer able to handle the humongous volume, variety, and the volume of data being processed. Like the first of all, storing the data and handle with the different types of data and processing the data in a stipulated time. So the single nodes or machines, they were running out of the storage capacity. So what was suffering? There was a need for a better solution. So one temporary or the short-term solution was there, that was the vertical scaling. By vertical scaling, meaning up the capacity of a single system by adding an external storage. So you can take it by this way. Let's say your computer is falling short of the storage. You can add an external drive to this, or you can even add the RAM to this. By doing this, you can increase the capacity. So this is known as the vertical scaling. So although it was a short-term solution, however, it was still very challenging, because every time it was not possible to scale up the storage capacity again and again in a very short space of time. Also, even if you are able to store the data using the vertical scaling, the processing time, it was a very time consuming activity. And every time vertical scaling, it was due to vertical scaling, it was a very expensive operation. And data required to be stored in a very processed format, like in the previous screen, as we were discussing about the data warehousing. So storing the data in the data warehousing was also a very tedious task, because it required data to be stored only in the processed format, not in the raw format. Second thing, the data required to be stored in the form of fact and dimension table. So not everyone was trained to do that. So that is why it was becoming very difficult to cope with that. So there was a need for a better solution, like from the data warehousing and from the vertical scaling, which had challenges like processing time, expensive, and like data to not having the feature of storing the data in the raw format. So the very first thing, the very first solution that was implemented, that was known as the horizontal scaling. Like instead of scaling up the single system, the once more solution was implemented, that was adding more systems or adding more machines. Okay. So this was also known as the distributed computing. So definition of distributed computing is that it refers to a system where processing and storage layer is distributed across multiple devices or system, like this. So basically a network was formed using a collection of computers. So the idea was that if we could connect all the computers together and leverage the storage capacity of all of these together, similarly leverage the processing capability like the RAM and CPU of all the system. If we do this, by doing this, the storage capacity was also increased, even the processing time also got reduced. So there was a huge improvement. It was also very economical as compared to the previous solution. And one more thing, that storage and like prior to this distributed computing, the database and data warehouse. So storage and processing, everything was happening in one layer. Here there were two layers. So let's say this is the network of computers, which we are terming it as the horizontal scaling or the distributed computing. So first of all, they had the HDFS, like you can ignore as of now. I'll be covering what is HDFS. So this is the storage layer and this is the processing layer. Data will be stored in the storage layer only, and that could be stored even in the raw format. And on top of that, whatever data was stored here, for processing it, the processing layer was there. Okay. So another like one example of this distributed computing was the big data, and later on as the technology more matured, so there was a concept of cloud computing. All of you are aware of it right now. So cloud computing system where we have various resources such as computing power, storage, and networking. Like these are all delivered over the network and accessed on demand using the URL. Talking about the distributed computing, like it solved all the challenges for the vertical scaling, expensive and all. So it emerged as a solution to the problem processing large amount of data in a timely manner. So like because they were, let me come, so because there were plenty of computers which were connected together, so although it was storing the although it was solving the problem of storage and the processing, so there was a one challenge, or there was a need for a mechanism to how to handle or how to manage so many devices together. Okay. And after that, like how to ingest the data into this. So big data was the mechanism which provided this thing, like to handle all the machines as a single storage, because in like under the hood, multiple machines were used. But when you talk about the users, so let's say I'm the user, so I'm giving okay, so we're talking about the big data, that it provided a mechanism to handle the network of machines, storage, data environment. So it also involves dividing a complex problem into small, more manageable parts, such that each small problem can be handled by a single computer. So this allows to handle large amount of data and to be processed in a short amount of time, also improving the reliability and availability of the computing system. So while this distributed computing term was there, so when there was a storage option, like when a storage was, so now a new term was there. India, like they gave a new term to this thing. The term was data lake, which emerged as a solution to the problem of storing the large amount of data in a cost-effective and flexible manner. It also gave the flexibility to store the data in its native format, like whether you could, it gave us the flexibility to store the data either in the Excel format, CSV format, image, video, or any other kind of format. So, which was very helpful. Now, like distributed computing and the data lake was there. So now it started challenging data warehouse in various aspects. First of all, first of all, it was a very economical solution as compared to the data warehouse. It allowed data to be stored in the native format. Horizontal scaling was also possible, and it allowed data to be processed, analyzed, and transformed as needed, without the need to first structure it. Like as in case of data warehousing, first we had to store the data in the process format in the form of fact and dimension tables. So to summarize this thing, the distributed computing in the data lake is have proved to be instrumental in enabling the organizations to harness the power of big data and also turn it into the valuable insights and actionable information. So far, we have discussed about a brief history of the big data, like how it is different from the database and data warehouse. We also touched upon the data, the distributed computing and data lake concept. Now, when we are talking about the big data, so Hadoop, the first ecosystem in the big data, the ecosystem. If you don't know the Hadoop ecosystem, then it is fine. Like the main things, we are covering the main things which you need to know in order to understand this part. Those are like in typical big data. In a typical big data framework, there are basically 4 steps or the 4 layers. First of all, we have the initial layer. Second, we have the data storage. Then we have the processing, and finally the consumption. Talking about the ingestion, data ingestion layer is helpful for ingesting the data from the external sources. And once the data has been ingested, it needs to be stored somewhere. It is stored in the storage layer. The storage layer is also known as. Now we are talking about the storage. Like once the data has been ingested, it needs to be stored somewhere, and the storage layer is also known as the data lake. As the storage layer is built on the distributed network of computers, so for managing so many computers, there is a resource management layer. Then once the data has been stored, so it needs to be processed. So the processing layer, in the traditional Hadoop data ecosystem, the traditional layer for this was MapReduce, and the storage was STFS. So if you talk about Spark, Spark also, like in a big data framework, fits into the storage layer. It only not storage. Then is also. So then there is a resource manager or the cluster manager, which is managing all the resources which are used for storage and the processing layer. Now, we have seen the Hadoop ecosystem, so let's talk a brief about it. So first of all, here we'll be now more discussing about the storage and the processing layer. So the storage layer here is known as the HDFS, which is Hadoop Distributed File System, which is a distributed storage layer. Then talking about the MapReduce, which was used for the processing, again using the distributed network. So here the storage problem was resolved, even the processing as well, but there was still a problem with the processing layer because coding programmers found it very difficult or challenging to code in the MapReduce because it was using the Java only, and it only supported the batch processing. However, after some time, there were a few companies which came up with new technologies like the Hive and the Pigletin. So Hive was like a SQL query, where the programmer could write the code in the SQL, and internally, even if they were writing the code in the Hive in the form of SQL, internally it was calling the MapReduce itself. And similarly, another option was the Pigletin. Then came the Spark in around 2013. Since its inception, it became the most popular framework for the data processing as compared to the other one, like the either MapReduce, Hive, or the Pigletin. It is said that it is 10 to 1,000 times better than the MapReduce. And unlike the MapReduce, like as we said that MapReduce is only applicable for the batch processing, Spark can process the real-time processing as well, and even it has support for the machine learning as well as the graph processing. Now, let's deep dive into the Spark architecture. So first of all, Spark uses the master-slave architecture. Why? Because it is built on the distributed storage, distributed concept, where we have the multiple computers, such that there is one computer which is termed as the master, or computer can also be termed as node, as we said earlier. And then there are certain other nodes which are known as the slave nodes. So how it works is master-slave assigns the task to the slave nodes. Now, slave nodes are responsible for carrying out the task assigned by the master node. So you can think it in that way, like this is team lead and these are the team members. Team lead is assigning tasks to the team members and they are actually responsible for carrying out the task. Now, master slave is a very generic term in the software engineering. Now, in terms of Spark and in terms of Spark, so master nodes or the process is known as the driver node, and the nodes are known as the executor node. So you can see in this example. So there is a driver process which is sitting on the driver node, and then we have the executor nodes. So this is master and these are the slaves. Then there is a cluster manager who is responsible for managing all the nodes. So what does it do is basically cluster manager, like whenever you submit any code to the Spark application or to the cluster, first it need to be connected to a cluster. When we say cluster means the network of computers. Okay. So driver process will request to the cluster manager to form a cluster. And even if there is during the processing, there is a need to scale up or scale down the cluster. By scale up means adding more computers, and scale down means removing the computers or the nodes from the cluster. So that task is handled by the cluster manager. And also it is a fault tolerant system. By fault tolerant, what do I mean is, in case out of all these computers, in case any computer stops working, in that case it is the responsibility of cluster manager to assign a new executor node. In such a way, the processing doesn't stop. It never stops because cluster manager is taking care of that thing. That is why it's known as the fault tolerant system. And in order to connect to a cluster, like this is kind of example of a cluster where we have the driver and the executor nodes. So first we need to make a connection. Your application or your system need to make a connection to the cluster, and that connection is known as the Spark session. Now, as we mentioned, Spark application consists of a driver process and set of executor processes. So driver process, it runs the main function and it sits on the node in the cluster, like the main node, the driver node. So it is responsible for doing the following things. First of all, it maintains the information about the Spark application. Also, it responds to the user's program or the input. It is also responsible for analyzing, distributing, and scheduling work across the different executors, which are part of the cluster. Now, executor. These are also known as executors, also known as the worker nodes. So these are responsible for actually carrying out the task that driver has assigned to them. So typically, they are responsible for doing following things. First of all, they execute the code assigned to them by the driver. And then they also report the state of the computation, like the work that they're doing. They're also responsible for reporting the state of that back to the driver node. So as we mentioned, the Spark also employs the cluster manager that keeps track of resources, like even if there is a need to, first of all, forming the cluster, scaling up the cluster, or scaling down the cluster. So these kind of things are managed by the cluster manager. So driver process is responsible for executing the driver program command across the executors to complete a given task. And as we discussed earlier as well, the executor for most part will always be running the Spark code. So the driver node, that can be driven from a different languages through the Spark languages. For example, like it gives like we'll be discussing this in our subsequent slides, that it gives us the flexibility to code in our favorite language. For example, if you're a Java developer, you can code in Java. If you're a Python developer, you can also code in Python. Similarly, R, Scala, and SQL. So it gives us various options. So the Spark application can be controlled through a driver process, and which is known as the Spark session, which we discussed earlier, like which is not just a connection which is made between the application and the cluster. So there is one correspondence between a Spark session and a Spark application. So although it is not mentioned in this slide, there is one more thing similar to, which is analogous to Spark session, that is known as the Spark context. So what happens is, in the initial versions of Spark, so there was a term named as the Spark context, which did the same thing which Spark session do. However, with the latest enhancement, Spark session also came into existence. So still, even the Spark context is not deprecated, it is still in use along with the Spark session. There is just one difference, that Spark context, it works with the low level API, and Spark session, it works with the high level API. Now, like some more thing about the Spark ecosystem. So at the bottom, we have the Spark core. And as we are talking about the different languages, so these are known as the high level APIs in various languages, R, Python, Scala, and Java. And top of that, we have certain more primary components like one is the MLlib. MLlib is a is the Spark's library for computing carrying out the machine learning and deep learning tasks. Then it also gives the stream processing option, which is used for the real-time analytics. Then using the SQL, it has the it provides the support to the SQL users by writing them by helping them to write the code in through the interactive queries. Graphics is used for the graph processing. So if you don't know about the graph processing, like let me give you an example for this. So there are two types of databases. One is the SQL database, kind of relational databases. There is another term named as the NoSQL database, which is an abbreviation for the not only SQL. So there are various examples for this. Some of the NoSQL databases can be document based. Some of them can be the key value pair, and one example is the graph database. So Spark also provides the support for the graph processing through the graphics library. First of all, talking about the Spark core, it is a main data processing framework in the entire Spark ecosystem, and it has its API in Scala, Java, Python, and R. And so there are three types of data structure that we'll be discussing in our next slide. So one of the data structure or the most basic data abstraction layer, which is known as the RDD. RDD is an abbreviation for. So as in addition to the Spark core, the Spark ecosystem includes a number of first-party components as well as the low-level APIs and high-level APIs. So the first-party components are like Spark SQL, MLlib, which we discussed in the previous slide. It has two fundamental set of APIs, the low level, which are also known as the unstructured APIs. Then we have the high level or the structured APIs. In low level, we have only RDD, which was the initial data structure of the PySpark. And with time, they introduced the high level APIs as well, which primarily used to deal with the structured data. There are two examples of high level API. One is the data frame, another is the datasets. Now talking about the first party components in the Spark ecosystem. First of all, we have the Spark. So it is a component that can be used in tandem with the Spark core. And it also has its API in Scala, Java, Python, and R. Like here, you can write the code in C. So what I was saying is like, it doesn't matter whether you use the Spark SQL, Scala, Java, Python, or R, like it is just a flexibility in which you can write your code in Spark. So internally, it is calling the RDDs. Okay. So even if you use Scala, Java, or SQL, so in everywhere, in a language or API, you will find the same performance thing. Okay, the same kind of performance you'll be achieving. So it defines an interface for the semi-structured data type, which is known as the data frame. So data frame, like those are familiar with the Python, so they might be knowing the data frame, which is similar to a table in the SQL. And then there is also a semi-structured version of RDD, which is known as the dataset. So what dataset is? Like dataset is only applicable with Scala and Java. It is not applicable with Python or SQL. So it gives us the benefit of both RDD as well as the data frame. So Spark SQL is a very important component of the Spark performance. So whatever can be accomplished using the Spark core can also be done by leveraging the Spark SQL. Talking about the MLlib. So initially the MLlib was there for the supporting the machine learning. It is the Spark's version of machine learning library can be used for carrying out the tasks related to machine learning and the deep learning. Over the time, Spark also introduced one more version that was the Spark ML. So difference between these two is MLlib is mainly MLlib is working with the low level APIs, that is the RDD, and Spark ML, it is working with the Spark SQL and data frame as well as the dataset. Talking about Spark streaming, it is the Spark's version of streaming. If you know, for streaming, you might have heard about certain services like the AWS Kinesis and Apache Kafka. So Spark also supports the stream processing. GraphX, as I mentioned, it is used for doing the graph processing framework for the NoSQL database, like the graph database. One example of graph database is Neo4j, as per my knowledge. So first of all, it's possible for you in this Spark code using the choice of your programming language. If you are a Scala developer, you can write the code in Scala. And one more thing about Spark is that it is written in Scala. So if you are a Scala developer and to write the code in Scala, then it is said that it's optimized. If you are a Java developer, you can also write the code in Java. Now talking about the Python. Python is nowadays a very popular language because It is used by the data analyst, business analyst, data engineers, data scientists, as well as the software engineers. That is why Python is also supported here. SQL, like those who are from the SQL background, like the relational database or the data warehousing, they'll find it more useful. And also Spark also has support for the R, like it has basically two types of libraries for Spark. The one is the Spark R, another is Spark Layer. Now we have the Spark architecture. Now let's talk about how to write a code in the Spark application. Like for next for 5 minutes, we'll be discussing about the theory part only. Like after that, we'll be coming to the practical part. So there are mainly three types of data structure as we are discussing: RDD, data frame, and dataset. So RDD is abbreviation for the resilient distributed dataset. So these are the fundamental and the most initial unit of Spark. So these are immutable. By immutable, what do I mean is, once you have created an RDD, you won't be able to edit it. If you want to perform any operation on the RDD, what you'll have to do is you'll have to create or form a new RDD out of it, but it is immutable. And now talking about the data frame, these which were added to the Spark ecosystem in the latest edition. So it is a distributed collection of data which is organized into columns. Like it is similar to the Python data frame or the SQL tables. So it is an improvement over the RDD because it's the structure of the data, which makes it easier to work with the structured as well as semi-structured data. So even Spark recommends to use data frame or data sets over RDD. It doesn't mean that RDDs are deprecated. These are not deprecated. These are still in use. However, Spark is making enhancement to the data frame and data sets only. Another reason for that is in data frame and data set, one thing is they provide the schema, and they also provide a concept that is the catalyst optimizer, which is more options for optimizing the code. Now talking about the data set, as I mentioned earlier, like it is similar to the data frame. However, it provides the benefits of both RDDs as well as the data frame, but it has one limitation, that it is limited only for the Scala and Java, not for the Python or SQL. So it provides the type safety, compile type checking, and optimization benefits of data frame. So one more difference between data frame and data set is that if you have written a code, so dataset also provide the compile type checking. For example, in your code, in case you have any syntactical error or the semantic error, then dataset, using the dataset, you'd be able to diagnose it during the compilation time. However, in the case of data frame, you will be able to identify the error only at the runtime. Now, that was about the data structure. Now let's talk about the operation. So basically, there are two types of operations which are performed in this Spark. One is the transformation, another is the action. So talking about the transformation, these are the operations that create a new RDD or data frame from an existing one, as I was mentioning earlier. Like these are immutable. So these are lazy in nature. By lazy, what do I mean is, doesn't matter how many transformations you create, it will not get executed until you perform an action on it. And it improves the Spark performance because there are less number of transformations which get executed due to this. So like this is basically the nature. Spark is faster as compared to the other data processing framework because of its. So we create DAG. DAG is an acronym for the direct acyclic graph. It creates a DAG of transformation that is executed whenever an action is performed. Some of the examples of the transformations are map, filter, group by, and these are mainly these terminologies are mainly used in the RDD. Now talking about the actions, these are the operations which trigger the execution of DAG, which is created by transformation and also return a result the driver program, and also used to write the output to any external storage. Some of the examples of actions include collect, count, reduce. Now, so far we have discussed about the overview of Spark and the history of big data. We also touched upon the Hadoop ecosystem. Then we did a deep dive into the Spark architecture. Now, as we were discussing in our first slide, that Spark is, it is said that Spark is better as compared to its alternative, whether it is Hadoop or MapReduce. So what is the reason for that? So because there are certain advantages of Spark, so let's discuss those advantages. The very first advantage is speed. So Spark is designed to be fast and efficient using the in-memory processing and also the lazy evolution to significantly speed up the data processing task. It can process the large data sets in real timely, like as we're talking about the stream processing, also the batch processing. And second thing is ease of use as compared to the Hadoop, which required specific programming skills in the MapReduce. So here you don't need to learn any new language. If you are from Java, Scala, Python, or whatever you're comfortable with, you can write your code in that language. Another thing is scalable. So it can easily scale out to the larger data set. It doesn't matter whether your data is 100 MB or 100 GB, you'll be able to work process it very quickly with the help of Spark. And then is the another benefit is the unified platform. So with Spark, you can perform the data processing, data analysis, machine learning, and the graph processing all under the same framework without having to switch between the multiple tools and system. So another advantage of this is, another reference of this is, like whether you are a data analyst, data engineer, even a data scientist or a machine learning engineer, you all can work collaboratively on the Spark platform. Another benefit is integration with the other big data tools. So Spark also provides an option to integrate it with another big data tools, even with the cloud tools such as the Hadoop, Hive, even some cloud storage options. For example, in Amazon AWS, we have the storage unit as the S3. In Google Cloud, we have the Google Cloud Storage. In Azure, we have the Blob Storage. So it has integration with all the terms. So there are a couple I'm done with the theory part now. So before we jump to the coding part, so there are certain references. So I'm given the references for the Apache Spark website. So where you will find the guides for the, if you are interested in the RDD programming, SQL programming, stream processing, even for the ML and graphics processing. Then I have given reference for another website, that is the Spark by example. This is also a very good website if you want to learn the basics and the architecture and all these things, so then you can refer the Apache Spark. However, if you want to use the specific examples, then I think you can also refer the Spark by examples. And then I'm recommending 2 books for although there can be more books. So I'm recommending based on the basis of which books I have read. So first book is the Spark, the Definitive Guide, which is a very good book. And from the beginner's point of view as well, it covers from the beginner's perspective as well as from the intermediate as well as the expert perspective. So let's say once you have read this book and after that you are at intermediate or the expert level, and then you want to see how to basically especially optimize the Spark code. For that, there's another book that I'm recommending, High Performance Spark. Both the books are from the O'Reilly. So now it's time for the hands-on session. Now I will go with some practical exercise. So there are various ways of running the Spark program. So you can run the Spark program either by installing first of all by installing the Spark on your system. If you want to look, if you are interested in installing the Spark, so then you can go to the Spark website and installation steps are mentioned there. And you can, for ID, you can use either the PyCharm or the Jupyter Notebook. And in my case, Spark is not installed on my system. That is why I'll be using the Databricks. So one more advantage of using Databricks is that the initial founders of the Spark, who founded the Spark, they went on to form this company Databricks. So it is a very good vendor for the Spark. So before running the program, first of all, we need to connect to a cluster, as I mentioned. So let's wait for 2-3 minutes. It may take around 1 or 2 minutes to connect. In the meantime, till the time it starts, I'll take around 2 minutes to just to walk you through about the Databricks and all. So first of all, in case you don't have the Databricks account, so no need to worry. So there is a concept of Databricks Community Edition. Apologize for the internet connection again. So you can go to the Google and search Databricks Community Edition. There you can create your account, and it is a trial version for 14 days. So there you can do your practice. So here, once you open the Databricks Community Edition, so here it will ask you to enter your username or password. In case you don't have the account, you can go to the sign up. And after that, you can enter your details, first name, last name, your email, company, title, phone number is optional. You can select the company and country. And after that, if you continue, then it will create a free account that will be a trial version applicable for 14 days. Like coding, we'll be doing these things. So very basic. So first of all, we'll see how to create the entry point to the Spark is the Spark session, which is nothing, just a connection to the cluster. Then a very basic unit, because I have worked for batch processing only using the PySpark and the SQL. So I'll be talking about the data frame only. So first we'll be discussing or we'll be seeing how to create the data frame by using a list or by using a list of dictionary. Then we'll see how to view the data once you have created the data frame. Then we'll also see how to view the schema of a data frame. And schema means the structure and the column name, data types of the data frame. Then how to select a particular column or the multiple columns from the data frame. And then like how can you add a new column or rename a column or a combination of columns to an existing data frame. And then the filtering the data, like how can you apply certain conditions to modify the behavior of your query. Then like this is all these examples will be in PySpark. However, as Spark also provides the option to run the code using the Spark SQL, so we'll be seeing the how to run the SQL queries as well, how to program and run in SQL queries. Then we'll be seeing the sorting, how to sort your data, and how to how can you drop a single column or multiple columns, and finally the aggregations of the group by operations. Just 1 or 2 more minutes. As it starts, then I'll start showing the code. Vikram, let's wait for 1 more minute. In case it starts, then we'll proceed. Otherwise, we can jump to the Q section. Okay, just 1 more minute.
Okay, sir.
Okay, fine. Okay, thank God. So as we discussed, first of all is the entry point for this Spark session. For this, it works in a similar way as to the Python. So from the PySpark.sql, we need to import the Spark session, and this is how we can create the Spark session. So this is the command that is used for creating the Spark session. I think first command will take a couple of seconds, and after that it shouldn't take that much time. And one thing I want to mention everyone that although this is taking time to execute that, but that is not because of this Spark. That is because of my slow internet connection, the connectivity issue that I'm facing. Otherwise, Spark is not that slow. It is very fast. Okay, so we are able to run this command. So this command, we have simply created this Spark session here. So let's see by creating the data frame. So the first example for creating the data frame that we'll see is, first of all, we'll be creating a list. List is a data structure in Python. You all know that here we are taking a list of numbers. Okay, so this is the structure. This is the command for running the list. So once we have created the list, if I'm providing the list name to run it. So here it is representing all the elements of the list. And if you want to see the data type of it, then there is a command name. In the parentheses, you can specify the name of the list. Now, what we'll be doing is we'll be creating a data frame using this list. Okay. So for creating a data frame, the command in the PySpark is spark.create data frame. So this is just to give you more reference. In case you want to see the help on any type of command in the PySpark, then there is a help command in the parentheses. You need to write the command. If you run this, so it will give you the details around the command, which is mentioned here in the parentheses. So let's create our first data frame. For creating the first data frame, I'll be using this command spark.create data frame, and then in the parentheses, we need to specify the 2 parameters. First of all, the data, then its schema or the data type. So as we already created a list, it can be a list, it can be a tuple or any file, anything it can be. Okay, so here we are taking the example of a list, and because these are the number elements that we created, so I'm also specifying the data type here. So if I run this command spark.create data frame numbers list comma this integer, so it will create a data frame. Okay, so our first data frame got created. Now similarly, as we have created a list of numbers, now we'll be creating a list of names. Okay, so I'm creating a new list, employee underscore list, and here I am giving you the list of names which are employees. So if I run this command, first it will create a list, and after that, again, as I created the data frame for the list of numbers, so here I'm creating a data frame for the list of strings. So here, because all the names are in string, so I'm giving the data type as string. Spark.create data frame, again list name and the data type. Okay, now jumping to list of tuples. So list and tuple, as we all know, like those, especially those are who are from the Python background. So tuple is another data structure in the Python. So here we are creating a list of tuples such that each element in the list is tuple. Okay, ID and name both we are taking together. So here, like although we did this in 2 steps, so here it can be done in a single cell as well. First, we are creating a list of tuples, and then in the second step, we are creating the data frame. Here, the data frame that we are creating, we are also storing it in a variable. So again, employee list, the list name I'm providing, and here I'm providing the schema, that is name and data type of the column. So if I run this, my data frame got created with the name df, and list name is employee underscore list, data frame name is df. So if I want to see the contents of the data frame, like the data that I've inserted, so how does it look like? For that, command is df.show, as in Python it is df.head. So here the command is df.show. So if you run this command, so it will give you the result, employee ID and employee name with the data. It got created. Now let's move to another example. Like here we so far we have created the data frame using list of tuples or using simple list. So another example for this is by creating the data frame. How you can create a data frame by using a list of dictionaries. Dictionary, again, it is another data structure in the Python. So which has a key value pair. All these are the keys or the like, and these are the values. So key will be created as the columns when we create a data frame by using this. So here, first of all, we'll have to import the 2 libraries. First of all, from the PySpark.sql, we need to import the row. Regarding the row, like just what I can tell you right now is like a data frame in any in Spark is basically a collection of rows. For that, we need to import a row. And because we are using some date operations here, that is why we need to import the date time. So I'm creating a new list employee in which each element is a dictionary, and in each dictionary we have details about the employees. Okay, so I'm creating a data frame here. Oh, sorry, list here. Once the list got created, so what another thing I want to show here is, first of all, using this list of dictionaries, first I'll be creating a data frame by using the pandas. So for that, first I need to import the library from pandas, which is a pandas Python code. Then here in the code is similar, PD, the alias that I've given to this library, pandas.dataframe employees. This is the example of the Python code. And however, in PySpark, you can also create the data frame from the pandas data frame as well, by again using the spark.create data frame, and in the bracket, you need to specify the pandas data frame. So here I'm not specifying the schema or the data type because the name was already mentioned there. That is why it will take care. So if I run this command, it will create my new data frame, emp_df, using this data. So throughout the exercise, we'll be using this data only. Now we have seen how to see the content of the data frame. Now we'll see how to print the schema. So for that, command is data frame name dot print schema along with parentheses. So if you run this command, it will print the schema of the data frame that you created in the tree format. Like on the top, we have the root, and then we have the column name, its data type, column name and data type, and then whether it is nullable or nullable equal to true means it can contain the null value or not. If it is true, then it can contain the null value. If it is false, then it cannot contain the values. So this was about the schema. If you want to see only the columns from the data frame, then you need, and the command is data frame name dot columns. So if you run this, it will display you the list of columns. If you only want to see the data types, then the command is data frame name dot dtypes. So the command is done. Now again, for displaying you the data frame name dot show. So like similar to the Python panda, so if you want to display only first 2 rows, then you can specify the number of that you want to display. If you remove it, it will display you all the records. So if you look at this output, so there are various columns: ID, first name, last name, basically details about the employees, email, phone numbers, courses, etc. So here, if you look at these columns, email and phone number, so entire data, entire content is not getting printed because it is getting cluttered. So for that, or it is getting truncated. For that, there is an option in the show command. That option is truncate. If you set truncate equal to false, so what it will do is it will not truncate the content. It will display you the entire data. So here, as you can see, now the complete data in the email or the phone numbers is visible. So it depends on your choice, like whether you want to see it in this way or in this way. Now we are done, like we have seen some examples for creating a data frame. It's time to see how to select a particular column. Let's say there may be a need where you don't want to see all the columns in a data frame. So in that case, you have the flexibility or the option to select a particular column or columns. So first of all, here again, the data frame name dot select. Select will be used for selecting the list of columns. So all the columns that you want to see in the output should be specified here in the single quotes or in the double quotes. Then you need to run have the show command, as we mentioned about we're discussing about the concept of transformations and actions. So because this is kind of a transformation and this is kind of an action, that is why you need to have this transformation. In order to run any select command, you need to run this show as well. And the select, if I write the star means all the columns. Okay, so because I've selected this star means all the columns, it is displaying all the columns from the emp_df data frame. So if I want to select only particular column, so this is one of the way data frame, then in the square brackets, I can specify the column name along with the quotes, single quote or double quote. What it will do is it will display the contents of only one column, that is amount paid. Oh, sorry, I didn't select this show command. Okay, it is giving some error. Let's jump to next part. So this is there is another way of selecting a particular columns. For that, like PySpark.sql.function, we need to import the call function. So call, what it does is initially what happens is, like whenever you specify any string in either in the single quote or double quote, so what Spark does is it treats it as a string only. However, in order to perform any operations on the columns, so we need to prefix it with the call or enclose it with the call. So it will select the call. Oh, sorry, I forgot to run this command. So after you import the call, then you'll be able to see select the call ID. Now, if you want to see the multiple columns together, then emp like data frame name dot select, and in the parenthesis, you can select the multiple columns by comma separated list. Okay, so first name, last name, and phone numbers, these three columns I have chosen. Now there is another way to select the particular set of columns. So this is more like a select expression, like this is more like a SQL type, or like the way how you select the column. So you specify the column names in the SQL terminology. So this is analogous to that. Here, because I'm using, what I'm doing is I'm instead of select, I'm using the select expression. And internally here I'm giving the name of the columns. And another operation that I'm performing is I'm concatenating these two columns to form a new column. Okay, separated by comma. For that, I need to use the concat function. Before using that, I need to import this from PySpark.sql.function. I'll import the concat. And after that, I'll be running this command. Like, because in this data frame, emp_df don't have a column name. So here if I run this by using the concat, so it will create a new column, full name, by concatenating first name and last name separated by comma. So far, like whatever commands we have written, either using the show command or the select expression. So what it is doing is it is displaying all the rows. So however, there will be a scenario where we may need to filter the data. For that, there is a filter command. So data frame name dot filter, and then in the parenthesis, we need to specify the column name using any of the naming convention that we discussed above. And here we need to specify the condition. Like here, what we are specifying is we need to filter or select all the rows where the last name equal to Paul. So here it is displaying only one record, which have a last name equal to Paul. So this was on the string column. However, these similar operations can be performed on the date columns as well. So here again, the syntax is similar. It's just that instead of like a data frame name and taking the column name in square brackets, I'm talking the another approach of selecting the column. Like this is another way of selecting column call, like enclosing the column name with the call function. And I'm using the operator dot between, which takes the date, which takes basically values between the specified values. Here I'm taking the date, that means where the last updated date between these two dates, 15th of 21 and 15 March 21. So if I run this, we'll filter the data on the basis of this condition. Now, like so far, whatever commands we have seen, that we have seen in the Apache Spark. So now there's a way to run the SQL queries as well. For that, first of all, we need to register the data frame. The data frame is employee underscore df, emp underscore df. First, we need to register it, and then we can query it. So for this command is data frame name dot create or replace temp view. Then the name that you specify in the next commands or the next sections, what we can do is we can treat this name that you specify in the parenthesis along with the single quote. So you can treat it as a table. So first, let's register it. And for running the SQL queries, then is another command spark.sql. And then in the parenthesis, these are the opening braces. Like you need to specify the 3 quotes. It depends on your choice whether you want to use the double quote or the single quote. It will work either way. These are the opening and these are the closing. And in between that, you can simply write your select queries. And here the table name will be the one which you specify here. If you write it here. So again, it is doing the same thing which were done in the previous step. We are selecting the first name, last name, ID, and also creating a new column by using the concat operator. Using the Spark SQL, like there's another way to filter, like where ID in 2,4. We don't need to use the filter command here because we're using the Spark SQL. So it will display the results on the basis of ID, where ID is equal to 2 or ID is equal to 4. Now let's see like how we can sort the data. Okay, like sorting the data in a particular sequence. So for that, there is one command named as the sort, data frame name dot sort, and then in the parentheses we can specify the column name. So what does it mean is we are sorting the data on the basis of first name, and for the order is ascending. So here what it will do, it will sort the data in the ascending order of first name. As you can see, the data is sorted now. Now, like in case you want to sort on the basis of any other column, not only the string column, like you can do either on the numeric column and date column as well. So here we'll take the example of the date column, last updated timestamp. It has sorted the data on the basis of last updated timestamp. And then like this was about the ascending. However, sometimes there may be a need to sort the data in the descending order. In that case, you can, how you can write is, you can write this dot descending along with parentheses. So it will sort the data in the descending order. So it will sort the data on the basis of descending order of last name. And then there is one option sort, there is another option order by as well. You can sort the data by using the order by command. And here, like what's happening, like when you sorted on the basis of customer from, so which was kind of a date column. So what happened was there were a few null columns, so which were coming at the top. So let's say if you want to change the order of execution in the basis of sorting, so how you can do is you can like give a condition or the specify the option such that when you are ascending, all the null options should go to the, all the null records should go to the last. So here the option is this function, ascending nulls last. So if you run this command, all the nulls are going to the last. Similarly, similar to ascending, we have the descending option as well. We can put the, when you are doing the sorting on the in the descending order, you can also specify that nulls to be coming in the top. So for that, command is descending nulls first. Now let's see like how can you add or rename the columns. So first of all, like as we imported on get, so even we can skip this part, but two other things, the lit function that we'll be using, we need to import this. So here we'll be seeing how to add the new column. So for adding a new column, there is a command name with column. So what does it do is, first of all, I forgot to mention, like when you're writing a multiple command, so you can split it into multiple lines by using this backward slash. Okay, after the dot notation, you can use the backward slash. So here in this select, I'm selecting which all column I want to be part of the output. However, if you want to add a new column, there is another way of doing this. So this is with column. So with column is a keyword and it has two parameters. The first is the name of the column that you want to specify. Second is the expression or the logic that you want to provide. So first I'm providing the using the with column, providing the employee name, this column, and then the logic. And why I have imported this lit function is because I'm using the comma here. So PySpark treats the comma as a string. So it may not be like, because it is kind of a dynamic thing. So it may not be able to append this. That is why I had to import this lit function, and concat also, like it is required. Now there is another thing with column rename. In case there is an existing column that you want to rename, for that you can use this with column rename. How you can do this is, like, again, data frame name dot select. I've selected all the columns, and the column that I want to rename, first of all I need to use this keyword with column rename, and then the column name that you want to rename. This is old name and this is new name. So there was a column name email. So if you want to keep it as the office email and then the customer flag, like, you can change it. Okay, now talking about the dropping columns. So like there may be a need to drop a particular column. For that, the command is data frame name dot drop. So here you can specify the column name. If you run this, so the first name and last name, sorry, which column we dropped, last updated timestamp. So here, instead of show, we have run this print schema, which is printing the schema. As you can see, last updated timestamp, this column got dropped. And here, like how you can drop the multiple columns together, you can simply put together in a comma separated format. Okay, now the last command that I want to show you is how to do the group by or the aggregation operations. For that, I'll be creating another data frame orders. So for that, what I'm doing is, first of all, like like initially I had created the data frame by using a list of dictionaries. So here another thing I'll be using is I'll be reading the file in the CSV format. For that, command is spark.read.format.option.load. In the read, as the name signifies, it is used for reading the files. And format, like which format you want to read, whether you want to read the CSV, Parquet, JSON, XML, that you can specify. In the option, you can specify infer schema equal to true. By what do I mean by this is, like, whatever the values are there in any particular column, so it will infer the data, it will infer the schema, what data type it should have. Then in the load, I'm specifying the path and the name of the file along with its extension. So if I run this, so it has created a data frame orders. So if I, sorry, the command is still running. So now a new data frame got created. And now if I want to see the contents of this. So if you see what has happened, sorry, the command is running. So if you see what it has done is, because I didn't specify the column name here, although it was able to diagnose the data type, but not the column name. So it has given the system created column names are coming like C underscore C0 underscore C1, C2, C3, like this. But I want to modify this thing. I want to provide my own columns. For that, what I can do is, there is an option named schema. In the schema, you can specify your own schema. So what I'll be doing is, I'll be creating a variable and force underscore schema. Then under this, like opening and closing braces, I'll specify all the column names and data types that I want to specify for this data frame, because I can see there are 4 columns. So 1, 2, 3, 4. So here I specified the 4 columns along with each data type: order ID, order date, order customer ID, and order status string. So again, if I run this, again, I'm using some different format for this. So now the data frame got created. Now, if you want to see the contents, again, I'll write the orders.show command. So now, if you can see, the column names are changed. Okay, order ID, order date, customer ID, and order status. So in order to perform any aggregate operations, first I need to import different functions which are required. I'll be taking a simple example only, the count, max, or min function. Again, from the PySpark.sql.function, I'll be importing these functions. Once I've imported, I can use this. So if I want to see the count star, like what are the total number of records here. in the orders table or the order data frame, it will give. So here, like this was another one notation, this is another notation, dot count. So it will also give you the same result. Now, if you want to do the group by on any particular operation and perform any aggregation like sum or anything that you can do. So here I'm in the group by, I'm specifying order date. On the basis of order date, I'm taking the sum of customer ID. Okay, so that is all from my side.
Okay, sir. Is it is it possible so I can read the questions out?
Sure. I'll try to answer.
Okay, so the first question is how to know if we need Spark or not? I mean, how much minimum data is sufficient for shifting towards Spark?
Okay, so as of now, like there is no such thing like the minimum amount of data. Yes, but the data should be, let's say it is in GB. So whether we need to go with Spark or not, that I can answer. So thing is like whenever there is a need, like whenever the amount of data that you are dealing with. So if it can be done by using a single machine, like if even the Python or R or whatever programming that you're using. So if it is able to handle that much amount of data, then you don't need the Spark. Spark is only required whenever you have a distributed framework. For example, let me give you a practical scenario. In many cases, what has happened, like I was dealing with data which was around 1 crore, 2 crore. When I tried to process it using the Python or the R, I wasn't able to do that. In such scenarios, PySpark may be used, because Python may not be able to handle that much amount of data. Although Python also supports certain parallel processing framework, like within the Panda itself, there are certain libraries. One of such libraries is Dask, D-A-S-K. Another such library is Modern. These are the Python's framework for the parallel processing. Still, the limitation of these two is, although these are also very beneficial, limitation is you don't have a cluster. Still, you only have a single machine, and using within that single machine, you can create your own multiple threads and then do the parallel processing. But still, PySpark will always be better because of the underlying architecture. Yes, you can jump to the next question.
Okay, so this is a question that many people are asking. So how can you, like, is it possible for you to share the resources for the notebooks and everything else that you presented?
Notebook, I think Vikram, I have shared with your team as well. Otherwise, after this call, like you can tell me the email ID. I'll share the email, this notebook, along with the steps how to import this notebook into the Databricks. I'll also share that step as well.
Okay, sir. So next is, if we want to write in Scala or Java, how do we go about it?
Okay, actually, it's not that difficult. Actually, I forgot to show it. Like if you're in the Databricks, so if you once you open to the Databricks, towards the top right section, top right corner, you will see that Python will be written on it. So along with the Python, there will be a drop down option. So in the drop down, if you click on that drop down option, so you'll be able to see the different language options. There you'll be able to see Scala, Java, Python, or R, even the SQL. Even if, let's say, you've selected the Python, still you want to run the SQL code. So how you can do is, like, you can write the percentage SQL percentage. In that case, you'll be able to run the SQL as well. Similarly for Java or Scala. I'm not sure whether only percentage option will be there, but from the drop down, if you choose Scala or Java, then you'll be able to run your command.
Okay, sir. Next is, in your example, how to take advantage of parallelism for data processing?
The parallelism example, its Spark is already taking care of it, because under the hood, it is already like the data is scattered across multiple machines, the network of machine, even the processing framework. So machines are already running in parallel. Otherwise, in RDD specifically, there is some parallelize operation. If you want to do further at the third level, then there is also an option RDD.parallelize.
So can range and row aggregation function also have to be imported in this way in Spark?
Range and
row aggregation.
Yes. I specified one library, PySpark.sql.functions, from which you can import any functions, whether you want to use the range or row aggregation function, even if the analytical function, like the rank, dense rank. So everything is available here. Although you have to import this, but what I want to say is, whatever pandas function or the aggregation, whether it is aggregation, sorting, whatever you have done using the pandas or using the SQL. So all the basic operations related to aggregation, sorting, adding, deletion. So everything is available in the PySpark. Okay, thank you so much, everyone.